All right, so next up in our conversation is rational functions. Rational functions are essentially a polynomial on top of a polynomial, really. A rational function exists in the form y equals p of x over q of x, where p of x and q of x are polynomial functions, and q of x can't equal 0 because you can't have 0 on the bottom of a fraction. Your base function is y equals 1 over x, and then transformations are written in the form y equals a over b, bracket x minus h, plus k, where a, b, h, and k are the same a, b, h, and k that you've always come to know and love. Okay, the kind of quintessential rational function there, that y equals 1 over x would look like this, where you have a horizontal asymptote at y equals 0, and you have a vertical asymptote at x equals 0. Okay. Okay, so the asymptotes are lines that the graph will forever approach but never hit. They are created by the non-permissible values of the function. We will get into more complicated factored forms of rational expressions too, and we need to talk about how each one of those factors tell us something about the graph. So understanding how the factored form of these equations work is vital to helping us through this section, as our graphing calculators don't always do a great job of showing them to us. Your graphing calculator will often look like a heart monitor on these guys. They'll just be this little blip because they don't quite know how to handle the asymptote. For the most part, if you actually bring your window settings in closer, you can get a better picture. Like by default, your graphing calculator is from -10 to 10 on both the x and y. If you brought that into -5 and 5 for both the x and y, often that will give you a bit of a decent, more decent, that's really bad grammar, but better picture. Okay, for solving, however, we're going to again focus on mostly on solving using graphing technology. So I had said I really want you to have a good understanding of that factored form, and this is what I'm getting at with this up here. Okay, so if you have a factor on the top by itself, a factor on the top that's not on the bottom as well, that will always create your x-intercept. So you figure out the value for x that zeroes that factor out, and that will give you the x-intercept. If you have a factor on the bottom that's all by itself, that will create your vertical asymptote for you. And then if you have a factor that's shared between the top and the bottom, that will create the point of discontinuity for you. Okay. As far as horizontal asymptotes go, essentially, the easiest way to look at this is with this following table. And we're looking at we're comparing the degree on the top versus the degree on the bottom. So if the degree on the top is the same as the degree on the bottom, your horizontal asymptote will be found by going leading coefficient divided by leading coefficient. Okay. If the degree on the top is bigger than the degree on the bottom, so like say we had y equals x squared plus 2 over x. Okay, so I've got a degree 2 on the top, I have a degree 1 on the bottom. There will be no horizontal asymptote there, but there still may be a forbidden y value because there still could be a point of discontinuity there. And then if I have small over big, then it will always be y equals 0. Okay, y equals 0 will be your horizontal asymptote there. Your diploma really likes to ask you questions around rationals and asking you for the range, where there's a point of discontinuity in the range, because your calculator doesn't show you points of discontinuity well. So it requires you to have to factor what you see and to see if you are able to find a point of discontinuity or not. Not only that, the factored form tells you the x value of the point of discontinuity, so you need to go a little further to figure out what that y value is, and you need the y value to give the proper understanding of the range. Okay, Bobo Button Eats DC. It's a little acronym to help you remember horizontal asymptotes. Big on the bottom, y is 0. Big on the top, there's none. Each are the same, divide the coefficient. Okay, if you like to memorize such things. Okay, So describe the transformations required to produce the graph of y equals 1 over x minus 2 plus 3 from the original graph of y equals 1 over x. Sketch both graphs. Well, I've given you the original graph of y equals 1 over x already. Okay, and that was the one I kind of just drew up here. So from a transformational standpoint, I'm going 2 to the right, so a horizontal translation 2 units right, and a vertical translation 3 units up. So my horizontal translation 2 units right will move this vertical asymptote so that it's on x equals 2 instead of x equals 0. And going up 3 will move the horizontal asymptote so that it's on y equals 3 instead of y equals 0. And then the rest is kind of the same as far as the pattern goes, because I'm still riding along the asymptotes. It's just that the asymptotes now are in different spots. Okay. All right, describe all you can about the graph of y equals x minus 3 over x squared minus 9. So the first thing you want to do is you want to look at that x squared minus 9 and say, hey, I can factor that. That's x plus 3, x minus 3. Then you want to take a look at the fact that I've got x minus 3 on the top and on the bottom. That creates a point of discontinuity. Okay, so I know I have a point of discontinuity at x equals 3. Now the problem with that is I can't just say x equals 3. I need to say the actual point of discontinuity. So I need the y value. So how do I get that y value? Well, I know that it simplifies to y equals 1 over x plus 3, but x can't be 3. Even though that x minus 3 has divided out in the simplified version, I still know that x can't be 3. So if I plug in the forbidden x value, I'm going to get out a forbidden y value. Now, what you have to be careful of is you have to plug the forbidden x value into the simplified version, because if you plug it into the original version, it's a non-permissible value. It's going to create it's going to create an error in your question. The whole question is going to fall apart. So you have to plug in the non-permissible value, but into the simplified version as well. So that's going to give me 1 over 6. 3 plus 3 is 6 on the bottom. Okay, and so I know I have a point of discontinuity at x equals 3 and y equals 1 over 6. So that's the point 3 comma 1 over 6. I also know I still have an x plus 3 on the bottom. That would create a vertical asymptote because that's a factor on the bottom by itself. I know I don't have a x-intercept because there's no factor on the top by itself. I know my y-intercept, I could just plug in 0 for x and get out 1/3. So my y-intercept is 0 comma 1/3. I know my domain is going to be real, except it can't be plus or minus 3. I know my range is going to be, I haven't talked about a horizontal asymptote yet. I have a horizontal asymptote at y equals 0 because I have small over big as far as my degrees go. Okay, so my range is going to be y is a member of the reals, except the two things y can't be. Remember, there's two. There's the horizontal asymptote and there's the y value at the point of discontinuity. Okay, so this is everything I just said. Vertical asymptote, horizontal asymptote, point of discontinuity. There's no x-intercept, the y-intercept, the domain, and the range. Okay, now if I was to draw all of that, I draw my vertical asymptote, my horizontal asymptote. The point of discontinuity needs to be a open circle. I could put my y-intercept there, and then I kind of follow that 1 over x looking pattern because this is still kind of a 1 over x looking graph. Okay, good job. All right, let's take that ink off. Okay, compared to the graph of the base function y equals 1 over x, the graph of y equals 1 over 2x plus 4 minus 5 has undergone various transformations. Choose the appropriate transformation from each list below. So horizontal stretch, first of all, right off the bat, I would want you to look at that and say, hey, I'm not in factored form. So I want to write that as 1 over 2 bracket x plus 2. Before I continue on my little journey here. So that's a horizontal stretch. Here's my b value. It'd be a horizontal stretch of 1 over 2. And horizontal stretches are about the y-axis, so that would be a 4. It's a horizontal translation left 2. Okay, so left 2 would be a 4 again, and then it's a vertical translation down 5, so that would be 2. So 4, 4, 2 is what my answer should be there. Whoops, sorry. I can't get my ink off. There, 4, 4, 2. Okay, awesome. All right, write the equation in factored form for the rational function shown below. The function passes through the point 0, -5. So the fact that I know it passes through the point 0, -5, that's my friendly point that I'll plug in for x and y and solve for a. Okay, so you always want to algebraically solve for a. Even if you think you know what a is, kind of based on where that horizontal asymptote is, which is awesome that you can see that, algebraically solve for a, okay? You have to determine the equation. So those are things that we're looking for when we ask you to determine something. Okay, so what do I know? Well, I know I have an x-intercept here, -4, so that's going to be a factor of x plus 4 on the top by itself. I know I have a point of discontinuity at x equals 4, so that's going to be a factor of x minus 4 on the top and bottom. And I know I have a vertical asymptote at x equals 2, so that'll be a factor of x minus 2 on the bottom. And so I write all of that out with an a value. I'm going to take my 0, -5 and plug it in for x and y so that I can solve for a. Now, when I did that, I'm ignoring the x minus 4 there because it's the same thing on the top and the bottom, so it doesn't really matter. So I'm just ignoring that to get my a value. 0 plus 5 is 5, 0 minus 2 is -2. I'll multiply both sides by -2 and then divide both sides by 5 and I get a equals 2. Okay, so my final answer is y equals 2, x plus 5, x minus 4, x minus 2, and x minus 4. Just a reminder, you do want these in your equation because that tells me you know where that point of discontinuity is. Okay, so even though it simplifies out, you want to keep it in your equation just to have the proper visual there. Okay. 4 different rational functions are given below, each with b is greater than 0. The rational function which does not have a vertical asymptote is which one? So if I don't have a vertical asymptote, I don't have an NPV. Okay, so when you look at these guys, knowing that b is greater than 0, is there a way to get a 0 on the bottom? So if I was looking at that guy, I can say right away, well, a can't equal the same thing as b because then I get b minus b and that would be 0, right? Do you see what I'm doing? So that has to have a vertical asymptote. Here, a can't be -b because if a was -b plus b would give me 0. Here, a can't be the root of b because the root of b squared is b and b minus b is 0. Here, obviously it's going to have to be d because, well, it's the last one, but what am I doing here? I'm taking a and squaring it. No matter what a is, once I've squared it, it's positive. And then I'm adding a number that's greater than 0. There is no way to get to 0 there. Okay, so d, there is no non-permissible values, which means it does not have a vertical asymptote. Okay. All right, good job. A student is analyzing the graph of y equals x minus a over x squared minus a squared and creates the following statements. Now, before I go and read those statements, the very next thing I want to do is I want to know what do I have to do with each of those statements. So I'm going to scoot right down to the bottom and get my direction first. It says the statements that are correct. Okay. So probably the first thing I want to do there is factor it. So y equals x minus a over x plus a, x minus a. Okay, so now I see that I have a point of discontinuity at x equals a. That is true. Point of discontinuity at x equals a. So number 1 is true. Number 2, there's a vertical asymptote at x equals -a. That is also true because I have x plus a as a factor on the bottom by itself. The vertical asymptote has the equation x equals a. Well, I can't be x equals a and x equals -a at the same time. So 3 is not true. 4, the horizontal asymptote has an equation y equals 1. That is not true because I have a degree 1 over degree 2. So it'd have to be y equals 0. So 5 is true. So the answer is going to be 1, 2, and 5. Okay, 1, 2, and 5. And these would be keyed when they say any order, like they would take 5, 2, 1, 2, 1, 5, 5, you know, anything. That's a perms and columns question. Okay, we'll get there later. To the nearest hundredth, the largest solution to the equation x plus 3 over x squared minus 5 equals x plus 3. Now, I think it would be a good idea here. I'm going to switch to a graphing calculator for just 1 sec. Okay, so I just want to quickly talk to you about how to input this in your graphing calculator. So in your graphing calculator, if you have a new Casio or a new TI, you would want to open up a fraction button first. So that's your ABC button on a Casio, or if you have the new black ones, it just looks like a box on top of a box here, but it's just in the same spot. Then you can go x plus 3 and then go on the bottom and go x squared minus 5. Okay, if you have a new TI, you can get that fraction opened up as well by going alpha y equals 1. If you have a white Casio or an older TI, you don't get the luxury of that button to be able to do that first. That's okay. What you want to do is you want to go bracket x plus 3, close that bracket. So the entire top has to be in its own set of brackets, and then divide by, and then the entire bottom has to be in its own set of brackets, okay? So x squared minus 5, close those brackets, and then you'd be good to go, okay? So you want to have that in y1, and then x plus 3 in y2. And then we'll graph. Okay, and then again, just take note of your picture here. It said what the largest x-intercept was, and so you're going to want to go to the one on the right. Okay, so I have to just skip over to here. So I actually had to skip to the third one there, if you notice that. So that's 2.45 altogether, okay? 2.45. Now I'm just going to switch back to the PowerPoint, and we have 2.45, okay? Awesome. Okay, algebraically determine the domain and range of this guy. Well, the domain is going to be real except for the non-permissible value. So I can see right away that x squared minus 4 would factor into x plus 2x minus 2. So I know my domain right away will be x is a member of the reals, but it can't be plus or minus 2. My range, well, I have the degree 2 over degree 2. So that'll be leading coefficient divided by leading coefficient for my horizontal asymptote. So my horizontal asymptote will be at y equals 1. So I know that y can't be 1. But now I have to also check for a point of discontinuity. So I want to factor the x squared plus 5x plus 6. That would factor into x plus 2, x plus 3. Okay, and so I can see that I'm going to have a point of discontinuity at -2. -2 what? Well, if I plugged -2 into the simplified version like this, right, that would get me -2 plus 3 on the top, which is 1. -2 minus 2, so that'd be what? -1 over 4. Okay, so let's just clear that. I've got a vertical asymptote at x equals 2. I've got a horizontal asymptote at y equals 1. And I have a point of discontinuity at -2, -1, 4. So you must justify what you write. Don't assume someone will fill in the gaps for you. This is what the directing word determine means, okay? So I'm trying to establish, because I know I have a horizontal asymptote and a point of discontinuity and a vertical asymptote, that's what allows me to now state what the domain and range are. So the domain is x is a member of the reals, but x can't be plus or minus 2. And then the range is y is a member of the reals, but it can't be -1 over 4, and it can't be 1. Okay. All right, good. Given f of x equals 5x plus 7 over x minus 3, rewrite the equation in the form y equals a over x minus h plus k. Then state the transformations that have been applied to this graph from the base function y equals 1 over x. I'm going to show you this in two different ways, just depending on the school you come from or depending on whichever way you find easier. I think the first way is easier, and I don't think a lot of schools teach it this way, but 5x plus 7 over x minus 3 simply means 5x plus 7 divided by x minus 3. So I'm actually just going to do that division, okay? We did polynomial division in the polynomial unit. So here I go. X minus 3 is on the outside, 5x plus 7 is on the inside. What do I have to put up here so that when I multiply it by x, I'll get 5x? I know I needed to put 5 there. So 5 times x is 5x. 5 times negative 3 is negative 15. And then I go to subtract and I get a remainder of 22. Well, that remainder of 22 never got divided by the x minus 3. So I can write this now as 22 over x minus 3 plus 5. And that is in the form that I was asked for in the first place. So now I know that my a value is 22, my h value is 3, and my k value is 5. Okay, so I could read the transformations based off of that. Door number 2, if you don't like that, what we do is we want to create an x minus 3. Because I have an x minus 3 on the bottom, I want to create an x minus 3 on the top. And I know that I have a 5x. So I know that if I introduced a negative 15, okay, then I could factor that 5 out and I'd be left with 5 times x minus 3. I can't randomly introduce a negative 15. So at the same time that I introduce the negative 15, I introduce the positive 15, which is essentially 0, which means I'm not actually changing the equation at all. But now I could go and factor the 5 out of 5x minus 15. And that would look like this. And now this portion here is just going to give me 5 over x minus 3. Sorry, this portion here is just going to give me 5 because x minus 3 over x minus 3 is 1. And then this portion here is going to give me 22 over x minus 3. Okay, and so I would end up with the same thing I had on the previous slide, 22 over x minus 3 plus 5. Okay, so now to state the transformations, I have, again, we're doing this on the base function y equals 1 over x. I have a vertical stretch of 22 about the line y equals 0 or about the x-axis. Horizontal stretch 3 units to the right, and a horizontal translation 3 units to the right, and a vertical translation 5 units up. Okay, horizontal translation 3 units right, vertical translation 5 units up. Okay, so we're going to solve this algebraically. Easiest thing to do is just multiply by a common denominator so I get rid of the fractions. So I'm going to multiply all of these terms by x times x minus 1. Okay, when I do that, I would have my x minus 1s would divide each other out there and I'd be left with x squared. On this guy, my x minus 1s divide each other out and I'm left with x. And on this guy, my x's divide each other out, so I'm left with 2 times x minus 1. Okay, NPVs are that x can't be 0 and x can't be 1. I always want to state my NPVs because at the end, I need to check my answers and make sure they're not NPVs. Okay, so now I'm looking at x squared equals x plus 2x minus 2. Bring everything over to one side so I can factor it. I'm looking at x minus 1 and x minus 2, which means x equals 1 and 2, but x can't equal 1. So you got to cross that guy out and then just conclude that x equals 2. Okay, we want to see that you know there's 2 answers there, and then we want to see that you know one of them doesn't work in the context of the question. So be careful that you're communicating all of that to us. If you just went to x equals 2, we don't know if you're just trying to cheat off your graphing calculator or if you're just not good at communicating or whatever, okay? All right. One of the factors of the denominator for the function f of x equals 5x squared minus 15x plus 10 over x squared minus 5x plus 6 is x minus 2. If this factor is replaced with x minus 1, a new rational function g of x is created. Compare the characteristics of the functions f of x and g of x with respect to asymptotes, points of discontinuity, intercepts, domain, and range. Okay, this is a great written response type of a question. Okay, so first thing obviously we want to do is factor f of x. So I know I've got a 5 there, and then if I factor that 5 out, I'll have x squared minus 3x plus 2. That will be x minus 1 and x minus 2 on the top, and then on the bottom, I've got x minus 2 and x minus 3. As we go through this, now I'm going to show you like the perfect answer, right? And my perfect answer is never to stress you out, but it's to help you kind of hone your skills to see where you should be going. And one of the things you should be doing is you don't just want to list information. You don't just want to say, this is the domain of f of x and the range of f of x and the domain of g of x and the range of g of x. I need you to connect the conversation together. I need you to say statements like, the domain of f of x and g of x are the same. They are blah, blah, blah. The range of f of x and g of x are not the same. This is because blah, blah, blah. Okay, that's what a compare question is all about. Okay, so I have the factored form of f of x, and then it says we are going to replace the x minus 2 with x minus 1, which means g of x is going to look like this. So I replaced the x minus 2 in the denominator with x minus 1, and now I want to compare all that's happening. Okay, so I'm going to do this in the exact same order that the question did. If you want to pause me each time, and then you can read my answers to see how your section compares to my section. Okay, as far as asymptotes go, the vertical asymptotes are going to be different now. Nope, the vertical asymptote is going to be the same. I'm going to have a vertical asymptote at x minus 3 in both cases. Okay, the vertical asymptote stays the same. The horizontal asymptote also stays the same. There'll be y equals 5. The point of discontinuity will be changing. So we'll get to that in the next section. Okay, so first of all, asymptotes. Both functions have the same vertical asymptote at x equals 3. Both graphs will have the same horizontal asymptote at y equals 5. So one point I want to make here is not only am I saying that they're the same, I'm also stating what they are. Okay, be as succinct as you can when you're doing this stuff. Okay, point of discontinuity was the next thing to talk about. Point of discontinuity, both functions have different points of discontinuity since the factor shared on the numerator and denominator for both is different. So see how I also stated how I know where to look for the point of discontinuity. F of x will have a point of discontinuity at 2, negative 5, while g of x will have a point of discontinuity at 1, 5 over 2. And again, I would have to have algebraically solved for those y values by plugging in the forbidden x value into the simplified function. Okay. Note, because I haven't actually said this yet, sometimes asymptotes and points of discontinuity are collectively referred to as discontinuities. So the question may just say, speak of discontinuities. That means the asymptotes and the point of discontinuity, okay? So consider them both. Okay, intercepts was next on our list. Both functions have different x-intercepts since they have different factors by themselves on the numerator. The x-intercept of f of x is 1, 0, while the x-intercept of g of x is 2, 0. So again, I said they were different, but then I also said what each one of them was. The y-intercepts will also be different. The y-intercept of f of x is 0, 5 over 3, while the y-intercept of g of x is 0, 10 over 3. Okay, last thing to talk about is domain and range. The domain of both functions will be different because the restrictions are different. The domain of f of x will be real, but it's not 2 or 3, can't be 2 or 3, whereas the domain of g of x is real, but can't be 1 or 3. And because the points of discontinuity change, that will also change the range. The range of both functions will also be different because of the different points of discontinuity. The range of f of x will be y as a member of the reals, but it can't be plus or minus 5. Well, the range, that should say range there, sorry, of g of x is y as a member of the reals, but y can't be 5 or 5 over 2. okay? Now, I know that that can feel a little overwhelming when you just watch that I've done it all, okay? But I'm hoping you paused along the way and tried each one of these sections yourself. But this is sort of the communication that we're looking at in a written response question like this. And this is why I said in a previous video, you know, you should be doing a rough draft of some of these questions first on the scrap paper that you have, and then go and do your good copy on the actual page, okay? All right, so that's it for rationals. Next up will be function operations. So I'll see you then.